Hello everyone. Let's start with our new topic, that is welded connection. Here in this lecture I will try to explain you about the welded connection, how it is work, its advantage and disadvantage, and for the welded connection how can we find out the length of welding to resist the force. In this lecture we will discuss about the advantages and disadvantages about the welded connection. So we know about the welded things and how welding done, that we have seen surrounding of us where welding is done. Now let's start. Welding is a method of connecting two pieces of metal by heating to a plastic or fluid state, which are without pressure. The various processes of an arc welding that are used in structural steel applications are as under: shield metal arc welding, submerged arc welding, gas shield metal arc welding. This welding is the various systematic types. Number 4, electrode slag welding, flux core arc welding, and stud welding. We know about the welding. For that we have to discuss the things, how the metals will be melted by the electrode that you have seen in many places. Now, which are the advantages and disadvantages of welded connection? So for that, first we have to starting about the advantages. The welded connections eliminate the needs for making holes in the member. Therefore, the effective section of the member is not reduced. This has a great advantage in the case of tension member design. Dear students, as we discussed in bolted connection, there are needs of create a hole in a member, but in this welded connection there is no need of making a hole in a plate, so the tensile strength is not reduced, so we can get the full strength of plate in the welded connection. Now number 2 is the structure has less weight as compared to bolted connection, because if we are going to do bolted connection, there are needed the connection by the bolts, and we know there is some weight of bolt, but in this case there is if we are going to do welding, then there is no need of bolts, so we can reduce our structural weight. Then welding process is quick and save time of construction. You know, welding is very fast process, so we can reduce the time in connection of each and every member. Number 4, the welded structure are more rigid as compared to bolted connection. There is a connection between two plates. The welding is merging that plate with the help of welding, and due to that we can get maximum rigidity at the junction. Number 5, noise produced is very less, therefore suitable for residential and silent areas. You know, if we are going to connection the members with the help of bolt, then there should be needed sometimes hammering on bolt for the connection, but in the case of welded connection there is no need of hammering, so we can welding without noise. Number 6, welding is practicable even if the completed shape of joint. In bolted connection, the appearance of bolt at the joint is every time we can see, but in welded connection we can merge the two plates by smoothing, and we can it can give us the good appearance. Welded connection give better appearance that I discussed earlier. Now the disadvantages. There are some of the disadvantages of welded connection is there that we have discussed. Number one, welding requires high skilled person. Normal labor can't do the welding. If suppose I am talking about myself, I can't do welding, because for that we should have proper skill of welding, because there need of earthing and heating process, all that things are there. Number two, the inspection of welded joint is difficult and expensive. Sometimes some of the connection is failure due to welding and leakage is done over there. So at that time we can't take judgment of from where it is failure. Number three, costly equipment is necessary to make the welding. For the connection of welding, there should be a electrode with that welding equipments are needed. So it is very much costly as compared to bolted connection, because in bolted connection we need bolts and nut for that. Number four, welded joints are brittle and have less fatigue strength. If we are going to demolish the bolted connection, we must have to that bolted connection by the removing of nut. But for the welding, we are hammering on the connection and that connection is break easily. So there is less fatigue strength in welded joint. Number five, members jointed by welding may distort due to heating of member. Sometimes if we are going to do welding connection, there is a heating produced. Due to that heat, members are distort. Number six, welding at the site may not be feasible due to lack of power supply. If our site is some of the remote places and if we don't have the power supply at that spot, so at that time we cannot do the welding connection. So this is the most important drawback of welded connection. Now types of weld. For the welding connection we have to clear idea about the types. There are some basic type of welding. First one is groove weld, second one is fillet weld, third one is spot weld, and fourth one is plug weld. Let's start with some of the important points for this groove weld. The groove will be made in two plates that we have to connect by this kind of groove. You can see over here, and this groove is filled by the welding by hitting these two connecting plates. So this is called as a groove weld. Now fillet weld. Fillet weld is most important for the structural design. In each and every case we must go for this kind of connection, that known as fillet weld. In this connection we should have right angle connection place. Without right angle place we can't do the fillet weld. Slot weld. In this case we are going to do just one slot at this point, and in this case we are going to fill that welding at particular spot. And plug weld, it is also like that slot weld. In that case we are going to do normal drilling in the connected plate. So these four types are welding types, and in structural design we always prefer the fillet weld as a welding. Now this is types. There are number of types in groove weld. This all figure indicate the different types of groove welds. In first weld there is a square pattern, right? Then after single V butt, top and bottom both V generated by us, single U butt joint, double U butt joint, single bevel butt, grooved double bevel butt, single J and double J butt. These are the groove welding types, and it is used sometime in particular structure, but majorly what we are going to do, we always take the connection by the fillet weld, and another type of fillet weld, this kind of detail is done by the groove weld. Now fillet weld, this is the most important for us. If we are going to do connection with the help of fillet weld, then fillet weld are widely used in structural engineering application. As we discussed, fillet welds are widely used in structural engineering application due to their economy and ease of application. It is very much easy to connect two plates or members with the help of fillet weld. There are approximately triangular in cross section. As I discussed, if there are some particular angular form between two plates, then and then we can do this kind of fillet weld. So it must be triangular in cross section. Fillet welds are most suitable in the following cases: two elements meeting at an angle, as we discussed, between angle and gusset plate. Number 3, between flange and wave plate, and we know what is flange, what is wave. If I discussed something about the I section, in that case the top and bottom of horizontal plate, that I section is called as a flange, and the vertical member is known as a wave. Number 4, beam bearing plates. For the connection, there are needed the bearing plate to bear the shear force, and for the connection of that we must go for the fillet weld. Number 5, between bracket and column. It is most important for the beam to column connection. Number 6, between beam and column, where the connection between beam and column, that should be welding is done by the fillet weld. Number 7, between column and base plate. It is most important thing. If we are going to do the steel structure for a building or for industrial building, there should be a foundation must be done by RCC. But for connection of that RCC foundation and the column of steel, there should be a plate between that. That plate is known as a base plate, and that base plate is connected by the welding. Number 8, for the slotted connection, as we discussed, sometimes slot is generated over there, and we should be go for the slotted connection. So this kind of activity is act in our structure, then we must go for the fillet weld. This kind of fillet weld is done over there. The first is angle and the gusset plate. This is our gusset plate, and this is our angle, which is connected by the welding, which is indicated here by the dark line. This is column bracket, and in this bracket, this column is also a steel member, this bracket is also a steel member, and the two member is connected by this dark line as a welding. This connection is beam to beam connection. This is our I section of beam, and this is also I section of beam. These two member is connected by this cleat angle, and the cleat angle is welded by the dark line. Now slotted connection. Sometimes the length of welding is very much higher. At that time, the surface length of member is not reachable that length, at that time we must have to provide slot between that member, and we will do the welding is somewhere over here, and we can maintain the required length of welding. This is beam bearing plate. This is I section as a beam, and this is our plate. Column base plate, as we discussed, this is our vertical I section of column, and this is our plate. That plate is connected by the member with the help of welding, is indicated over here with dark line. This is our built up section. Sometimes the I section is not readily available in market, so we have to make that I section at on site with the help of welding, which is indicated over here in the triangular shape, and this is the plate connection with some member. So this kind of fillet welds are done by us on site with the help of welding connection. Now these are the symbols of welding for the purpose of which kind of welding is done over there. So it is most important for the engineer as well as the contractor. So we can explain that this kind of welding is done at particular junction. The standard welding symbols used on a drawing for the different type of weldings are shown in below. This is fillet weld. This is concave fillet weld. Sometimes the straight this kind of angle we are going to generate it by the welding, but it is smoothening by the internal curve. Then butt welding, the square butt, V butt, bevel butt, U butt, J butt, flat V, this kind of welding we are using butt welding. Now, so this symbolic pattern must be indicated in every drawing for the on-site welding connection. Now, it is the notation that used in a drawing for the welding. This arrow is indicated that you have to done welding over this point only, right? This symbol is known as field weld symbol, means you have to do welding on site. Sometimes our welding must be done at factories, but some of the connection can't be done at factory. We must have to do that welding at site, right? This is the size of welding, means length. Sometimes we are going to weld two members with intermediate space between them, means what here indicated, we have to done length of 50 mm welding, then leave the 100 mm for next welding. After that done 50 mm welding, left 100 mm, right? This is the fillet weld with concave, and this 6 is indicated is the size of welding, how the dimension of that welding required. Clear? Good. Now, as we discussed, this is our symbolic pattern, and I have discussed this, the side below, what it is indicated, a circle, what it is indicated, the site of weld near the fork on the horizontal line, that this all the things is indicated by a symbolic pattern that we have discussed. Now, properties, how the fillet weld works, right? So this two plate is welded for the connection, and it makes a right angle between there. So this area is filled by the welding by heating these two plates. First plate is heated somewhere over here, and this plate is melted somewhere over here. By this welding, this whole portion is melt, and it is together, and it will create the hard things. Clear? So from this kind of connection we are going to do at the site using fillet weld. Now for the welding we have to clear idea about the size of welding. It is most important thing for the resisting of force that can be resisted by welding. So the size of normal fillet weld shall be taken as minimum welding leg size. The size of fillet weld should not be less than 3 mm nor more than the thickness of thinner part. मीन्स यहाँ हम 3 mm से कम कभी भी वेल्डिंग नहीं कर सकते, बट मैक्सिमम कहाँ तक कर सकते हैं, जहाँ तक मेंबर की थिकनेस हो, यानी स्मॉलेस्ट थिकनेस ऑफ दैट टू प्लेट विच वी हैव टू connected by the welding. So if our plate size is up to 10 mm, then minimum size should be 3 mm. If our plate is from 10 to 20, then minimum 5 mm welding should be there. 20 to 32, then 6 mm. 32 to 50, then it is 8 mm. Right? 10 mm for the minimum size of welding. Clear? So this kind of minimum welding should be used for each and every welding connection. Now the most important part, that is throat thickness. It is inclined line from the right angle corner to the our edge of the welding. The throat thickness of all fillet weld, the shortest distance from the root of the face, the weld. The effective throat thickness of a fillet weld shall not be less than 3 mm and shall not exceed 0.70 times of his size of welding, where A is the size of welding. So the effective throat thickness is equal to K into size of weld. That K is the constant and it is 0.7 for actual our all the cases. Means this is our vertical length, this is our horizontal length, and this inclined length is known as a throat thickness, which is 0.7 into S. Right? So it length is going to give strength of the welding. So the equation for that throat thickness is Tt is equal to 0.7 into S. S is the minimum size of welding. Now end return. If we are going to do connection of two plates at that time, the length of welding must be done by two sides of the plate, but for the shearing purpose it should be do some welding at the edge of the plate, and that edge of the plate welding is known as end return. The fillet weld terminating at the ends or side of the part should be returned continuously around the corner for the distance of not less than the twice of the size of weld. Means end return is greater than 2S, where S is the size of welding that we have discussed. Right? For the getting maximum size of the welding, you should have to go for the page number 80 on IS 800. There is given that the size of maximum welding must be the thickness of plate minus 1.5. That 1.5 is the clearance for the plate. Now overlap. In case of lap joint, the minimum lap should not be less than the 4 times of the thickness of the thinner part, or 40 mm. Means we have to take overlap minimum 40 mm or the smaller thickness of this plate into 4 times. Whichever is more, we have to take the more distance between there as a overlay. Clear? Now, the effective length or area of welding. The effective length of fillet weld shall be taken as only the length which is specified size and required thread thickness. The minimum length of fillet weld is 4 times the size of weld that we discussed. Intermediate weld. The fillet welds can be provided continuously, intermediately. Effective length of the intermediate weld should be taken as a large of 4 into size and 20 mm. Okay. The clear spacing between the effective length of intermittent fillet weld shall not exceed 12 into thickness for compression and 16 into thickness for tension. Right? So we have to do this much overlap for the connection. Now groove weld, that we know we have to make groove over here and it can be filled with the welding and melting of this plate, and this groove must be done by us, and the cost of that groove is more as compared to fillet weld. Okay. Now for each and every case we must have to find out the length of fillet weld, right? And that welding length must be done by the using of force and thread thickness. We know about the thread thickness, but what is Q? That Q is the strength of the welding, and that welding strength must be calculated by this equation, which is given on page number 79 in IS 800/2007. If we are going to put that value in code, we are getting the two value of the design strength of the welding. One is for shop welding and another is for field welding. For the shop welding, it is 189 Newton per mm square, and for fillet weld it is 158 Newton per mm square. So whenever we want to find out the welding connection, for that we must have to find out the length of welding. That welding length is finding by the equation of, we have to make this as a master, means LW is equal to P upon TT into FA. This FA is known as FWD, means P upon TT into FWD. FWD having two value for shop welding and for field weld. TT is getting from the size of weld, which is between maximum size and minimum size, and this force is given, and it is we have. So we have to find this length of welding, and we are going to learn that welding connection by finding out the length of welding. So for the getting clear idea, in next lecture we are going to discuss on particular case as an example. So you should getting the clear idea about that. Okay, thank you.